Now, let's look at this question. You are all welcome to this morning class on solving heat of combustion of methane. Now, let's go. We will start by writing the equation of reaction. Methane burns in the presence of oxygen to yield water and carbon dioxide. We balance the equation. Hydrogen is 4 here. 2 times 2, 4. Oxygen is 2 plus 2. So 2 times 2 is 4, 2. So plus heat. So this heat released is actually the heat that was used to raise the temperature of water by 40 degrees Celsius. So recall that this heat, the heat lost from this reaction, is equal to heat absorbed by water. So having known this, you now say that if actually the heat lost is equal to the heat absorbed by water, and heat, you recall that heat absorbed by any substance is equal to the product of mass, specific heat capacity, and the temperature change. So from the question, mass of water is 100 grams. Specific heat capacity is 4.2 joules per gram per degree Celsius. And change in temperature is 40 degrees Celsius. If you press your calculator, you get 16,800 joules of heat. Now, this is the quantity of heat released by the reaction or absorbed by water. So what you do is they asked, what is the heat of combustion of methane? So this is actually the heat released. But heat of combustion, which is designated HC, let's just use HC. Heat of combustion is actually the heat released divided by number of mole. Number of mole is N. Now, we have gotten the heat released, which is 16,800 joules. Let's look for the number of moles. You now recall that number of mole is mass divided by molar mass. And if you check the question, the mass of methane is 0.16. The molecular mass of methane is 16. So the number of mole is 0.16 divided by 16. We are going to get 0.01 mole. So this is the number of mole of methane that burned. This now implies that heat of combustion of methane is 16,800 joules over 0.01. So if you press your calculator, you get this. 1,680,000 joules. And this is the heat of combustion. Converting to joule per mole. You now convert to kilojoule. You recall that 1,000 joules gives 1 kilojoule. Therefore, 1,680,000 joules will give X kilojoule. So to find X, this one over 1,000 equals X over 1,680,000. So when you cross multiply, 1,000x will give you 1,680,000. So x will give 1,680,000 divided by 1,000. So 3 zeros will cancel 3 zeros. The heat of combustion will now be 1,680. That is 1,680 kilojoules per mole. And that is the heat of combustion of methane.